going to look at is the converse of the Pythagorean theorem. So yesterday you did the Pythagorean theorem. You learned that if something was a right triangle, then a squared plus b squared equals c squared. And now we're going to look at the opposite of that. So now we take the hypothesis and switch it with the conclusion. We learned that earlier this year. So what I'd like you to do is we're going to look at the side across from here, okay? And I just want you to compare the a squared, this sum, which are these two segments, the squares, plus the other one, okay? So when we make it right and right angle, and I'll do my best to get as close as I can. That's pretty close. You can see those are equal. I know they're a little off. Notice I'm not completely at a right angle right now, but the closer I get, the more equal they'll be. So that proves that I can prove it's a right triangle if I can show a squared plus b squared equals c squared. Now over here, look at angle, the green angle here. Is that acute, right, or obtuse? Okay, hopefully you're going to say obtuse. And when it's obtuse, you'll see that the side across from it, the square of it, is greater than the sum of the squares of the other two sides. So when that's obtuse, then when the angle here is obtuse, the side across, the square of it's going to be greater than the sum of the other two squares. Now I'm going to come out and I'm going to make it acute. Okay, so now I have an acute angle. Now compare the two. Now that the square of this side is less than the sum of the squares. So we have three different situations where this side is less than, the square of it is less than the sum of the squares of the other two sides. We have the, no, difficult to do, the equal to, I know I'm a little off. And then we have the greater than. So that's how we're going to fill in our first part of the notes. We can use this to help prove what kind of triangle we're dealing with. So if c squared equals a squared plus b squared, then we know angle C is 90 and ABC is a right triangle. The angle C they're talking about, just like the GeoGebra thing I just showed you, is the side across from angle C. So this is C, and that's across from angle C. That's what how they're describing it. If c squared is less than the sum of the squares of the other two sides, then angle C, the angle across from that side, must be less than 90, and triangle ABC is an acute triangle. If it's greater than, angle C is greater than 90, and it's an obtuse triangle. And we just need to remember one more thing. We already studied this earlier this year. That in order for three sides to form a triangle, just a reminder, we've done this already in an earlier chapter, the sum of two sides must be greater than the third side. And we talked about that, and we showed the examples of kind of if they weren't, then the two segments would just lay on top of the other segment. They wouldn't meet. If they were equal to, then you just kind of have two segments laying on top of the larger segments. They have to be greater than so that it lifts up a bit to make that triangle. Okay, so then we move down here. If a triangle is formed with the sides having the lengths given, is it acute, right, or obtuse? If a triangle can't be formed, say not possible. So the first thing you can do here is double check the sum of two sides is greater than the third side. 9 plus 40 is greater than 41, so I know this can be a triangle. Now your next step is to identify your longest side. Okay, your longest side in this one is 41, and that is going to be your C side then. Okay, so don't always take it as the right, the one listed last is your C side. It's always the biggest number. So if C is 41, I'm going to set that one by itself, the largest one by itself, and I'm going to do the sum of the squares of the other two. Okay, so I did 9 squared plus 40 squared. And I put a blank here because I don't know if it's greater than, less than, or equal to. I evaluated those and got 1681 equals 1681. So if a squared plus b squared equals c squared, that's a right triangle. All right, I'm going to do one more with you. Okay, so again, the first thing I check is 6 plus 7. Is that greater than 8? Yes, it is. So that's a good thing to check because I got to make sure it makes a triangle. So 6 plus 7 is greater than 8. So then step 2, what's my longest side? My longest side is 8. So that is my C side. So C is 8. So that's the one I put by itself over here, whatever the biggest one is. And then I do the sum of the squares of the other two. When I did that, I found that the C squared was less than the A squared plus B squared. And going back to here, when that happens, it means it's an acute triangle. So that's where I got that. All right, what I'd like you to do is push pause, and I would like you to try the next 3 problems on your own, and then push play when you're ready to check your answer. All right. So here are your answers. Again, I checked 7 plus 8 is greater than 11. C is 11. Found that C squared was greater than the sum of the squares, so it's obtuse. Over here, if you remember to do that first step, 1 plus 4 is not greater than 6. So right away I know that's not a triangle. So I can't figure out if it's right, acute, or obtuse. It doesn't even make a triangle. Over here, if you get confused in number 5, how am I going to know which one's the longest? Plug them into your calculator. And you can see the decimal equivalent so that you can compare them. I also know the square root of 9 is 3, so the square root of 7 has to be less than 3. And because this is 14 and the square root of 9 is 3, this has to be greater than 3. So I can kind of estimate them. And then I did my work there, and I got them equal, so it's right. All right, and the next one, explain why angle P must be a right angle. All right, well, one thing that I can't really go straight to the converse of the Pythagorean theorem is I'm missing a side here, so I don't really know exactly what I should do. So I'm going to use this triangle over here, and I'm going to figure out what kind of triangle this is. So again, here's 15. That's my C side. Okay. So I said C is 15. I did the sum of the squares. I found they were equal. So I've shown RSO is a right triangle. And since 15 is the longest side, I know the 90-degree angle must be across from that, which is angle R. Then I said, okay, well, these two triangles definitely aren't congruent. I know that. But perhaps they're similar. And you can prove that. We have the vertical angles here. And then if you use SAS similarity, if I do smaller, so that would be 6 to the smaller one here, 9. 6 to 9 simplifies to a 2 to 3 ratio. And 10 to 15 simplifies to a 2 to 3 ratio. So I have the congruent angles, I have the same ratio, so they are similar. Oops, sorry about that. Now that I know they're similar, I know the corresponding parts are congruent. So notice how I wrote my similarity statement. And that means angle R corresponds with angle P. And since I've already shown angle R is 90, that means angle P is 90. So the converse of the Pythagorean theorem can be used to prove if a triangle is right, acute, or obtuse, but don't forget to check first if it is a triangle. Okay? And again, your examples are here. Given 3 sides, what you can do. Okay? And then you'll be working on the homework for today.